Hello, scholars. I want to create a quick video on parallel lines and transversals to help you understand some of the angle relationships that we are going to be using this year. As a first step, you need to be able to tell me what angles are the same and what angles are supplementary. As a second step, an important step, is that we need to be able to prove it. We need to be able to say how we know that, because math is all about proving that something is the way that it is. So I want to take a look at this picture. First, it says in the picture below, lines X and Y are parallel. If they're not parallel, this is not going to work. And line T is called a transversal. A transversal is a line that intersects two or more other lines. Usually, we're talking about parallel lines. A transversal doesn't have much meaning unless it's intersecting parallel lines, because a transversal helps us know about a bunch of angle relationships that helps us prove whether they're the same or different. This says use a protractor to measure each of the 8 angles that are formed. I have a protractor. If you want to grab a protractor, you are welcome to do that. I'm going to drop this protractor right on this intersection right here. And this line will point to the measure of this angle that is formed by these two lines meeting. So it points to 120. So I'm going to write down that A is 120 degrees. Now let's look at B. You can always use a protractor backwards, or you can turn it. It does not matter. But looking backwards, this angle right here, what is inside of this? Well, it starts at 0 and it goes to 60. It looks like what this is pointing at. So I'm going to write down that this is 60 degrees. Now I'm going to do this next part pretty quick because I know what's going to happen. It looks like if I put this line right here is pointed at, oh my gosh, 120. And for this one from 0 to here, it looks like this angle measure is 60 degrees. And friends, this is just going to keep happening. That's what happens when we have a transversal and parallel lines. I look at this, boom, pointed at 120 and 60. Feel free to grab a protractor yourself and see this. But again, we're going to see 120 and 60. We end up with just 2 angle measurements in all these little corners here. Only 2 angle measures that work. What do we notice about this? Well, it looks like angle A is congruent to, blast from the past, friends. We know what this means. It means same shape, same size, right? In this context, we're just using it to say that these are the same angle measures. They are same, okay? Is congruent to angle C, which looks like, this is 120 as well, which is congruent to angle E, which is congruent to angle H. They are all 120 degrees in this case. We can say the same thing about these 60-degree ones. We can say that angle B is congruent to angle D. Well, let me switch pens here. This one's dying on me. Angle D, which is congruent to angle F, which is congruent to angle G. So we have this set of congruent angles and this set of congruent angles, and that is always going to happen when you have 2 parallel lines and a transversal. Of course, we can add as many parallel lines in here as we want. We're just going to get another set and another set and another set of congruent or supplementary angles. Ooh, supplementary adds to 180. Oh, we knew that was going to happen with a straight line, yes. We'll talk about that as well. This says also label the interior and exterior of the parallel lines. So all this stuff in here is interior, inside the parallel lines, trapped by the parallel lines. We're going to label this as interior, interior, and everything outside the parallel lines, not between them, boop, is exterior. This is exterior. Outside the parallel lines. Okay, now we've got everything labeled. Let's talk about how we know these things. I'm going to have to keep coming back and forth here. How do we know that these angles are congruent if we don't want to measure them? How do we know just based on the fact that I've got parallel lines and a transversal? Because this relationship always happens. I want you to be able to say these are congruent because they are what type of angle. And that will allow us to prove what we know. So, vertical angles, blast from the past. This is 7th grade stuff. You already know this. Pairs of angles, pairs of, what do I want to say here? I'm going to say opposite. That's a P. Opposite angles formed by intersecting lines. Okay. You know this, right? In 7th grade, you did this, right? And you said this and this are the same because they're opposite of one another on the same intersection. And this are the same thing. Vertical angles straight across from one another on the same intersection. So examples of that. Oh, here's an intersection. So A and C are congruent. B and D are congruent. They are vertical angles. Let's write one of those down. We've got angle A is congruent to angle C. We've got this and this. We've got F and G. I'm going to write down E and H. It's congruent to angle H. Okay? What's the relationships? They are congruent. Okay. We're going to keep rolling here. It's really important that you pause and look at these examples and understand these examples, or this is going to be pointless for you, and I don't want this to be pointless for you. Okay, so straight angles. I kind of wish this one wasn't on this sheet. I just want to call it supplementaries. Angles that you can move or manipulate that form a straight line and add up to 180 degrees. Straight angles, talking about angles right next to each other. These are also called supplementary, and that's the relationship we're going to talk about here, okay? Anytime we put a big angle and a small angle together up here, we get 180 degrees. I could even do like this and this. I've got 180 degrees, right? But straight angles are talking about the ones that are right next to each other. I just want you to be able to identify supplementary angles. A big angle and a small angle is going to give us supplementary angles. So let's write this. Like we could say angle A plus angle B equals 180 degrees. I mean, we could say E and G equals 180 degrees. We just know if we put a big angle and a small angle together, we're going to get something that is supplementary. And that's the important idea here, okay? That you be able to prove when something is supplementary. Okay, alternate interior angles. Angles inside, interior, right? Inside, interior, the parallel lines, and on opposite sides, alternate. That's where that word comes from. On opposite sides of the transversal. So we've got two examples here. We've got D and F. They're both inside the parallel lines. Notice they're both 60 degrees, right? Both inside the parallel lines, and they're on different sides of this transversal. This is on the left side. This is on the right side. So we can say angle D is congruent to angle F. We could also say that C and E, both inside the parallel lines, but on different sides of the transversal. Angle C is congruent to angle E. What's the relationship? They, of course, are congruent. We are proving that they are congruent. Okay, moving on. We've got alternate exterior angles. Same idea, except they are outside the parallel lines, but on opposite sides of the transversal. Okay, so looking up here, what are outside? They have to be outside, so we're going to pick one from the top, one from the bottom. Notice these are both 120 degrees. They're both outside of the parallel lines, so we call them exterior angles. They're alternate because they're on different sides of the transversal. We can say that angle A is congruent to angle H. We also have one more set. We can say angle B is congruent to angle G because they are alternate exterior angles. So make sure that you pause and really understand, why are we calling those alternate exterior angles, and how do I know that they are? How can I identify them on my own? Finally, last set of congruent angles. Angles in the relative same relative positions. Angles in the same corner. So basically, if I take this and I copy it and I put it right here, some angles are gonna match up with one another. A is gonna fall on top of E, B is gonna fall on top of F, D is gonna fall on top of G, C is gonna fall on top of H. Those are all examples of corresponding angles. So I'm just gonna write down a couple of them. Angle A is congruent to angle E because they are corresponding. Let's write down this. Angle C is congruent to angle H because they are corresponding angles. And again, we are proving congruency. They are congruent. So the really important thing is that you be able to prove congruent angles using these 4 words, and then you be able to identify supplementary angles. That's what I'm going to quiz you over later this week. Okay, you should know what to work on next. Please put this in a safe place, and you can use it for the things that we are working on coming up. Thank you.